Come on. A little slow on the conference machine. Okay, so thanks everyone for joining our software developer training panel. We have JC, Bain, and Matt here to talk to us about best practices of communication of software projects, resources, governance, and culture. And yeah, they're all developers at Kitware, and we're excited to have them share their experience with us. So I'm not sure who's going first.
I will be going first.
Okay, great. Take it away, JC.
Great, thanks, Jess, for the introduction. Yeah, this presentation has three parts. The first one, we're going to talk about managing open source communities. The second one going to be about the structure of documentation. And then the third one going to be about best practices. It means I will start first, then Matt will speak, and then Bain. And without further ado, we'll get started. Oh yeah, first thanks to the Ski Institute for doing that work, NIH, and then some prior work from Bain, and also the open source guide online are a valuable resource for finding information about the open source community and whatnot. Okay, managing open source community is in the context of the open source software there's a lot of ways to deal with that. There's like a few books and publications, some websites. The challenge, one of the challenges in the context of scientific, where you have given usually the framework, some single developer who are like putting together algorithm, what we call the hero code, or like there's less of a community around software, and that brings some challenge. And then challenge between like coming up with publication and then also maintaining a community of software. And yeah, there's some challenges in the context of scientific software. Now, why do we want to organize and standardize that? The size of community limit activity of project, and what is the size? It's like the interest of software, the ease of access. I mean, the size is bounded by the ease of access in software, and also the availability of the community. It's creating that community go beyond than just like publishing the code. There is a bit more structure to set up and put in place to have a thriving community. And also when you open your software, there's some additional work that come with that. They're going to see your software, and they're going to be coming up with use case you haven't faced. They're going to ask more features. They're going to ask more questions, and then sometimes it's also create conflict, and all of that is cool, and it's good, and there's a way of addressing that and handling this type of situation. And now, like, how do you get started to create a community? Is to find a home where people can come up. It's going to be like on GitHub or GitLab and whatnot. Create a website, choose a license, have a way of contacting you, find a nice visuals for it. And then another thing is, if you have a user, identifying this user who are like, really going the extra mile and community, you can capitalize on that by sharing success stories and involved in the process of the community, finding additional funding and whatnot. And if you ensure they are successful, then your platform will be successful also. And also always good to identify like conferences and outlets to communicate and advertise to your target audience, and identifying also social media outlets. Then, as hinted earlier, balancing software and also the scientific work is a challenge. And ideally, if you can identify avenue where you can fund your software and also work on the scientific aspect, then you can combine both, and it's nice. Another challenge is that the community will always expect new feature. It means always maintaining is not good enough. You need also to provide new capabilities. And managing time is also a challenge. Yeah, what are the strategy? As mentioned, combining the software engineering aspect with the scientific work and making that as a first-class citizen, delegating when possible, and also while we want to do our best and provide a complete answer, it's better to provide feedback quickly and not let users and contributors waiting too long. It's a matter of balance. Yeah, as a maintainer, you will have to provide a useful tool and useful software. Note that you cannot accommodate every user, and scoping what your application can do and what are the limits and bounds of it is important. Time is critical, and another thing that's important is knowing when it's okay to acquire technical debt, and finding compromise and documenting this compromise. Not over-engineering is also important, and we all want to do well, but learning how to say no and delegating and communicating is important, especially in the context of open source, with this like round the clock worldwide set of users that will always be active all the time. The key aspect is to make people feel welcome, and there's something called the contributor funnel, and it's like it starts from the user all the way to maintainer, and what the goal is to reduce friction in that funnel and avoid what we call leaks. It means you don't want to lose people along the way. And during that, the remaining of the tour, we're going to see how to optimize and make good material to encourage and maintain that funnel of contribution. For every contribution, it's important to provide feedback early, and it means acknowledge, and that could be as easy as like clicking on this like emoji icon, or also providing a small comment indicating you don't have the time or you have the time, provide a link to additional resources or providing next steps, and that apply at every level from like newcomer to more well-seasoned user. Often we find ourselves repeating ourselves, and when we repeat ourselves too much, trying to combine this answer into a frequently asked question, listing, improving the documentation is important, and will allow you to easily reference that into question. And question of user help you identify what are the issues in your existing documentation, and whenever possible, taking the time to improve that is key. Another challenge is often you're gonna face like a conflict, and this different type of conflict. The first one is there is different technique that achieve the same goal, and how do you deal with that? And it's by like reaching out and engaging and communicating, and keeping things open for having different implementations, setting a benchmark, and usually if you have like a pluggable infrastructure that enable that, and ultimately different type of user may benefit also from different techniques. If you have similar application, usually it's perfectly fine. I think reaching out to try to develop common ground and reusable components is a way of mitigating that. And if there's different group working on the same technique, often there's different aspects of the same technique, and being forefront about what are these things, and catalyzing one effort versus the other, and making sure folks are not you're not like in a sort of toxic environment. And the key is the takeaway are like, yeah, conflict. You will have conflict, and it's important to engage communication early in the process, and communicate, and share credit whenever it makes sense. Now that we come to the credit, why is it important to share credit? As developer, that it's important for motivation to properly credit, and there are ways to make that happen. Sharing credit in the context of open source should be public as much as possible. There is way of sharing what they call badges, and this could be like in the form of like electronic badges, or it could be as far as like 3D printing something like in the ITK project, first-time contributor or contributor of release were offered like a 3D printed ITK logo. There's like a lot of different ways of being creative to reward contribution. Mentioning contributor in release notes and publication is important. Outlining what are the first-time contributor for a project. Making use of when you create commit, there's a specific commit trailer called the co-authored by, which allow you to reference multiple authors, and then they're all going to show up publicly, and their contribution will be acknowledged in the contribution graph. Reference folks in talk whenever possible. And also the last one is when contributor have demonstrated skills and the ability to somewhat safely manage and work with the infrastructure, providing them with like maintainer access, write access whenever it makes sense, will smooth the whole process. And how do you support that whole process and you maintain it over time? Publicly assigning responsibility, documenting that is one way. Having people prove their competence, and documenting what are the process to access to, when will you get like broad access to a project and whatnot, and trying to formalize these processes is important. For newcomer, identifying what they call good first issue, and there's like a link that provide an avenue to implement that, for example, in the context of GitHub, and there's a way to identify and create what they call good first issue that don't require understanding of the full big picture of the project, but you can focus your energy on a localized problem. Another one is code of conduct, and code of conduct is a matter of what most of us consider common sense into a set of written rule, and there is useful template that can be built on to formalize that, and they can be referenced down the road. And the next slide is an example of what was done in one of our community. And in the link, you can find a link to, you can find additional information about the process and the discussion about adding a code of conduct. And in this one, what's interesting, you can see the co-authored by as different part of the process. And the first commit on the left, it's about adding the pristine version, and then the slide under the screenshot under illustrate the different updates and why we did them. And then the one on the right is like a screenshot of how we adapted the initial code of conduct by removing the enforcement guideline and why that was done and whatnot. But yeah, that's like an example of like providing credit and documenting what was done. And the last one is to have a clear contribution guideline. And in the remaining of the presentation, we're going to see some more like practical example how to do that. But that's an important aspect for keeping your community engaged and bringing new contributor and new user in the project. And now we have reviewed all like the high level aspect. We're gonna see how to put together documentation, and Matt's gonna take over.
Thank you, Jean-Christophe. So communication is so important to building your community. Next, we're going to talk more about documentation, which is a huge part of that communication, and how to do documentation, how documentation is organized, the anatomy of open source documentation. And there's a consistent anatomy, head, shoulders, knees, and toes to open source documentation that you may be familiar with, that's kind of evolved in our communities over time. And in this next section, we're going to go over the common pieces of good open source documentation. And from a high level, what are the pieces of good open source documentation? We start from something that's small and concise, that's focused on the goal and the mission and the purpose of the project. And with different types of documentation, they expand to be more volume and to be more detailed until you get to the point where you have documentation that's very specific at the code level. And beyond that too, you can provide fingers and links and appendages out into related information, like where the source code is located, or documentation that's embedded in discussion forums or chats online. So next slide, please. Here is a categorization of the different pieces of the open source anatomy, starting from the high-level mission down to the specifics that we're going to discuss. The first is starting off with a name and your mission statement of the project. Next, installation instructions, then getting started guide. From there, an examples gallery, then tutorials and a reference guide, citations and further references, and finally links to related information. Next slide, please. So first, the name and the mission statement, and that helps a community member identify what does this project do, which is the most important thing of the piece of the project. And starting with the project name, which is the smallest, but probably the hardest thing to determine. So start with the project name, and you can have a fancy name that's difficult to pronounce. And if you want people to understand how to pronounce it, then you can provide a pronunciation. If not, you can just leave it open for interpretation. But starting with the project name, and then also following that with a 1 to 2 sentence that describes the mission statement or the purpose. For example, in ITK, we have the Insight Toolkit is an open source cross-platform toolkit for n-dimensional scientific image processing, segmentation, and registration that tries to describe the purpose, the goals, and the vision. The shorter, the better. And after that, you can follow with more detailed information, such as the target audience and governance model. The goal is to communicate what a project does and make it easy to describe. And also for people that are trying to package it in package managers or reference it in a journal article, they'll often use this one-line summary of the project. So put a lot of good thought into that. It's not uncommon to find projects where you'll have a presentation, a README, diving into the project, and you have no idea what it does. So you don't want that to be the case for your projects. So start off with a good summary of the project. Okay, after getting to the summary, so next slide, we can understand how do we get this project? How do we obtain the open source project? And ideally, you'll have installation instructions that are simple and concise. You might need to indicate constraints on the platforms if that's required. And if there's multiple ways to get to the project, ideally start from the simplest and most accessible and go into the more detailed, more involved ways of installing the project. So as we've been discussing, ways to deliver zero installation applications by just visiting a web page. First, hopefully start with that. And then beyond that, if you have a desktop application, how to get the installer. Then if there's a Python package, hopefully how to easily install the Python package. And if you need to build some compiled C++ code or Fortran code, provide descriptions on how to do that. Okay, next slide. After you've installed it, you have the software. What does the community member want to know? How do I get started and how do I use this? And keeping their attention, we want this to be a very quick guide on how to go from having the software to seeing the value that the software provides. What does this do? What does this give to me, this functionality? So short examples that hopefully focus on the core value proposition of the software, or the main feature, what's unique about what this software, what it does, and focus on producing that output, producing that result that it generates, and not specifying parameters or options or going the complicated route. We go from data to results as quick as possible. Okay, next slide, please. And after someone knows how to create some piece of information with some example demo data, the next thing they're going to do is try to understand how they can use the software to solve some problem that they have for themselves and with their own data that they're working with, if we're talking about scientific software. And Bain will be talking more about this next. He did some great work in the PyVista community. He's a master at that. But generally, these are very, very valuable pieces of documentation, the examples that you provide to the users. And that's a way for people to make connections with the problems that they have, and also get started and go from data to solution very quickly as a template. The approach that you can use of determining what examples you create and how do you present them is what we could call the Trebek method. So thinking about Jeopardy, think about the questions that people have related to the problems that they're trying to solve, and then answer these questions in an example. And that way it can be concise and focused on problems that people will have. And ideally with these examples, if they're presented in a gallery format, so someone can quickly see what an example does, that's very helpful in navigating the documentation. Next slide, please. Going beyond examples, which are usually shorter and self-contained and just looking at one specific issue, tutorials are helpful. And these help explain to the community member, how does this software work? They are longer and more detailed than getting started, and are more comprehensive than an example. Jupyter notebooks are wonderful for presenting tutorial information. They can provide insights into architecture, how to do specific things, pitfalls, best practices. And when creating tutorial material, you can lean on the teaching material best practices that you know from teaching materials in your courses. So that means having small modules that someone who's learning about your system can go and take in an hour-long session or less, and kind of know that they've conquered and learned that information. Include in the documentation, start with the learning objectives, so that someone who's going through the tutorial can find the right components of the tutorial that provide the information that you need. That's also helpful for you yourself, guiding the content of the tutorial so that you know what you're actually trying to portray in this section. Include with the tutorial some didactic material that explains the software or the theory or background behind it. Also hands-on material, so it's interactive and engaging. And exercises are also very helpful, even if they have the answers, and that people can get more engaged and really learn from the material, and finally conclude with a summary. Next section, please. Finally, some of the most detailed information are reference guides or user guides that go into all the details of a comprehensive understanding of the details of the software and how to use it. Typically, you won't expect someone to read from start to end all the material, but they may be looking for specific guides on how to work with specific features of the software. And this provides a detailed description of functionality, background navigation, and includes API documentation. Next slide, please. And then finally, citation and further references. And this helps someone cite the material if they're writing a journal article, also find related reference material on journal articles that are related to the software or background theory information or related material. And inside your citations, we can provide a few different types of citations. Some are papers or journal articles, and it's also helpful to provide a citation that can be used to reference a specific version of the software when people want to reproduce work that's published. You have a version of the software. A citation on GitHub Zenodos is very helpful for doing that automatically. You can create a DOI that's associated with specific versions of your software when you create a release. Then you also want to provide information on related journal articles, but also similar software. As JC was saying, there's also often overlap, and it's helpful to provide links to similar software or related software. Next slide, please. And finally, reach out with more information with different links, providing links to the source code, to any discussion forums, packages, code of conducts, and derived projects. So that's an overview of the anatomy of documentation. Next, I'll pass the ball to Bain Sullivan, who's going to give you more details on how to create this documentation in the best way.
Awesome. Thank you, Matt. I just want to confirm that people can hear me okay. I had some audio issues at first, but I see a thumbs up. Perfect. Yeah, thank you, Matt, for that excellent overview on how to build your documentation, how to structure your documentation, how to include the most relevant materials. JC, if you want to go to the next slide, please. I want to now talk about taking all of that documentation that you've built, how Matt described and outlined really, really fantastically, and just describe a handful of best practices. There's plenty of other things we could really go into and plenty of other best practices, but I think these are some of the most critical for building sustainable documentation that will help your software thrive. And just sort of something to keep in mind, that I at least keep in mind, is that the more users and the bigger the community gets around your software, the more work you have to do, whether that's answering questions, making sure it installs in everybody's niche architecture and different platforms and things like that. And in my mind, good documentation and the more documentation you have helps alleviate that burden from the maintainers and you as researchers, so you can focus on the software at hand and building tools that then people can just go to, look at the documentation and get up and running in no time. And I think examples, installation instructions, all those things are really, really critical. So now I want to talk about just a handful of these best practices that are just automate the whole process and empower your community to contribute and maintain and update your documentation in full. So go ahead and next slide, JC. The first and foremost best practice is design your documentation in a way in which it can be automatically generated and updated. So this means, structuring the text and those high-level overviews, installation instructions in things like RST or Markdown that then can be used by tooling like Sphinx documentation or MK docs that sort of aggregates those simple Markdown docs or RST docs into a beautiful, rich, interactive website. So use those sorts of widely adopted tools. Keep your actual documentation to be super stripped down, simple files and things like that. And then once you are building them with tools like Sphinx or MK docs, and there's plenty of other fantastic tools out there, use continuous integration and deployment services to run the build and then collect all the artifacts, collect that HTML website and deploy it. GitHub Actions has recently come out with some really nice workflows that just like out of the box will work if you have like Markdown files, or I think even Sphinx, where it will then deploy your site on the GitHub pages, and it's all right there next to the repository, and you can integrate these actions with your pull request checks and different workflows. So there's fantastic tools out there. Read the Docs is another longly established tool for continuous integration deployment of building and hosting your documentation. Really great community around Read the Docs, and tons of great support there. One of the biggest benefits I see from automatic generation of your software is that it empowers your whole community, all of your contributors, to contribute to the documentation, maintain the documentation, fix typos, fix things that are just flat out wrong. If you typed out an equation wrong or something, it empowers everybody to just open a pull request, they fix the documentation, and then your CI/CD does all the building, does all the integration, and does the deployment for you. And so that way you as maintainer or owner of the software can sort of become step further and further back and let the community, let software sort of maintain itself. And then, of course, the big thing here is on every release, publish the documentation and keep that alive for that version of software. And go ahead and next slide. And so on that note of whenever you publish a release and you then publish the associated documentation, it's really critical, especially with research codes, to keep different versions of your documentation alive. While things like installation instructions hopefully don't change between your release cycles, I guarantee your API documentation will change between your release cycles. And so it's really important to make sure you're publishing and saving multiple versions of documentation so that your community can access those, because if someone's writing their paper with version 25 and you're now on version 36, they still need to be able to reference that documentation and make sure that their science is reproducible for the paper they're publishing or the work that they're doing. Because a lot of people just can't run the latest version. Maybe your latest version is broken on Windows architecture or something like that. And so it's highly important. There's lots of great examples of big community projects that make sure that their software is available or documented across versions. And sort of a point that I like to use that justifies this whole thing is, well, your software, when you publish it to a package manager like PyPy, the Python package index, or Conda, or insert name packaging infrastructure for your coding language, it maintains a history that cannot be changed of your release versions. And so your documentation should match that as well, because people can always go back and install a previous version. But if the documentation's missing, then effectively a lot of those previous versions can be really tough to use, if not useless. Read the Docs has really excellent tooling and integration for this that I think just works outside the box. So that way, as you publish and issue tags, Read the Docs just archives it, and there will be a little button that you can hit and it will just have it there for you. Next slide, please. And so just to give some examples of some projects that do this, I think Xarray is a really fantastic example where they have tons of previous versions of their documentation, and so many other projects out there like NumPy and Pandas do the same thing. We recently did this in PyVista, and so we only have a handful of the last releases, just because we build really big documentations with lots of visualizations embedded in them, and so it was hard for us to maintain multiple versions. But we recently did this as well, just a couple examples. So go ahead and next slide, please. Next slide, JC. Oh, perfect. Yeah, build often. So on the note of continuous integration services and all of that, it's really important to continually build your documentation, because if you're automating the build process, things will break along the way. Your dependencies might update and the doc build will break. And so it's really important to have these things integrated into the status checks and the different CI checks that you have with your unit testing and functional testing of the software. Let the documentation build be just another status check or functional test of the software itself. And so that means whenever a contributor opens a pull request, that the documentation is built and validated, and it makes sure it actually comes completes successfully. Another really fantastic thing to do is to set up cron jobs from your main or master branch of the software that just continually rebuilds the documentation, make sure it's in a live working state. And so that way, when you get to your release point, it helps alleviate that burden of like, okay, it's release time, I need to make sure everything works. It's like, well, if you are building your doc all the time, then this will help alleviate that and consistently keep your documentation in a valid state. I want to use the phrase consistently there, just because, you know, things will break, and it allows you to fix them as you are between releases and sort of alleviate some of that pain. Next slide, please. And just sort of some examples of this. So in the PyVista repository on the left here, I just have a little screenshot of our documentation workflow that's constantly running. Every single pull request, every single pull request it runs on, and then as soon as the pull request is merged to the main branch, it's run. Then we have cron jobs that run it just in case there haven't been recent contributions. And so it's just constantly building, constantly building. You can see there's some X's where it's red, sometimes it's green, but it's really, really critical that you keep building it. You know when things failed, so that way you can track back to when something broke your documentation build. And there on the right here, you can just see it's another status check that we don't merge a contribution unless the documentation is also building successfully against the software. Go ahead, next slide, please. So example validation. So Matt gave some great details on how to write examples, how to create sort of those minimal examples where it's just like really, really focused use case, and then the full-blown tutorials where you go through. But I think I've run into this problem a lot. I'm sure many of you here have as well, where there's some research code out there, and then there's another Git repository of some examples. And those examples are written 3 years ago. They should work, but they don't. And you go to run them and you run into all kinds of crazy errors because the API, the software has changed. And so I think a really great best practice is to actually run all of your example codes as a part of the documentation build. Tools like Sphinx have really great plugins that make it so when you embed a code snippet in your documentation page, it actually runs that while it's building the documentation and captures the output and then embeds that output in the documentation itself. And it's a really effective way to do functional testing. Functional if you're building those tutorials or even just a second layer of unit testing on your software to make sure that it works in the way that you're telling users how to use it. It's a really, really critical step. And again, it makes it so your software just works. So a user can go to your documentation page, they see a code snippet, they just copy and paste it. And because you are validating in your CI that snippet runs, when a user goes and copy and paste it, it will also just run for them. And it's a really, really fantastic, empowering for users. So go ahead, next slide, please. And I want to give, here's an example of some API documents in PyVista where a contributor opened up a pull request, and here on the left figure, they put in some example code in the doc stream of the API, basically like, here's a function, here's how you use it. And then in the middle, it goes and that's our CI routine that ran on that pull request. It validated. I couldn't find the exact test because there are thousands of them. So I just sort of highlighted that several thousand of them passed. And then on the far right here, you can see the actual produced output. So this is generated with Sphinx, where you can see, you can kind of line up some of the same code with what's in the screenshot on the left to the right. You can see now a user can just go and they can copy that code snippet and it will just work for them. And we validate it works on that version of PyVista. So no matter what, if you have that version of PyVista out, you're looking at the docs, copy that code snippet, it will just work. Next slide, please. And I want to give another example of that, where you're building tutorials, those sorts of examples, where users can basically like, here's a common use case of how to use our software. In PyVista, we've built an extensive gallery of examples where we have like, here's a common visualization task you might want to do. And that's sort of just on the screenshot on the left, there's an overview of some of the examples. And on the right, there is one of them in particular. So it's basically a whole web page that can be downloaded as a Jupyter notebook or a Python script file. And we validate that is a self-contained tutorial or example that users can download and run without any additional data. It will just work. And then what's really awesome about Sphinx is there's plugins that make it so, yeah, so we are running that code in the notebook or in the documentation build. And then the outputs, like there on the right, the two cows that are perpendicular, that visualization that was created is then embedded into the documentation itself. And so so that way a user comes to the page, they see exactly what the code is going to produce. They can copy and paste it. It will run. It will just work for them. And I want to go on a bit of a tangent on the value of examples and tutorials like this. I think these are some of the most effective ways to build users around your software and to empower people and let them figure out how to use it. Because if they can find say you just have a handful of tutorials and these are the most common workflows of your software, it gives people a really, really powerful launching point, something to stand on and then use your software to go do what they want to do. And so they can get started and then adapt your scripts and your tutorials to sort of tweak them to get them to where they need to be. And we've seen really, really tremendous success on the PyVista project with this, where I used to have some great graphs that showed usage download metrics and things like that. And when we introduced this examples gallery, we had this hockey stick graph where users just started coming to our page and realizing they could just take our examples, do what they need, modify 1 or 2 lines, and all of a sudden they have the visualization they want. And it was really, really empowering for users, really helped our software really, really take off and bring a lot more people onto the project. That's my side rant about the value of examples. So go ahead and next slide, please. And I think the last best practice I'm going to touch on is just instruction for contributing. I think consistency really goes a long way in making sure when you're talking about your software, talking about how to use it, you're using the same phrases, you're using the same language, even as things as simple as, if you're talking in the first person or third person, it can really make a big difference when a user is coming to it and they feel consistent, they have an idea of what's going on. It's, I think, very critical to develop a contributing guide that outlines these styles and outlines, okay, if you want to contribute your own example to our documentation, here's like our workflow of how you should do that. This is how you should step through it, outline your example, things like that. And then go ahead and next slide, please. I want to give an example from PyVista. So we have quite an extensive contributing guide which just goes over all the different ways you could contribute, whether that's answering discussion questions or contributing new code or writing new examples and tutorials or improving the API documentation. And the screen grab on the right here is just a small section of our contributing guide where we outline, like, if you're writing the API docs, make sure you do it in this really strict format. And this makes it so it renders really beautifully on the documentation website, makes it so that way whenever users are going from one end of the code base to the other, the instructions for how to use it look the exact same. The look and feel is familiar. They can go in there and really know what's going on really, really quickly because they get used to that consistent style. So those are I think some of the most critical best practices. There's plenty of other really great processes to put in place when you're building your documentation and trying to share information about your software out there. That's all I have for these best practices. I think we're at the end of the presentation at this point, so I think it'd be a great time to open up for questions.
Thank you to all of our presenters. We have some time for questions. So let's open it up for some. Are there any from attendees? See any in the chat yet, but feel free to either unmute yourself or type them there. I think, Jack?
Yeah, I have a question.
Yeah, go ahead.
I just had a quick question about how do you manage and balance the time spent writing documentation for a release? Like, how does it look in your guys' sprints, basically?
I mean, but like the idea is not to write documentation for a release, is to write documentation as you create the software. Because if you wait for your release time, you are not in the flow of writing. You may forget what's happening. It's as part doing work of like documenting. Like if you add a new feature, you document it, or you post something on your forum, then you can link that later on in your release note. But it shouldn't be like a massive effort of writing this release note.
I'll also add something there, because maybe the question is also about like, just like when you make a release, there's, I guess, a one pager about this is what's changed in the software. And I think one of the ways we approach that on the PyVista project is we just make sure every pull request that comes in has a meaningful title, and we ask for our contributors to update that description as best you can. And then when we create the release notes, we actually have an automated routine that goes through, looks at all the commits, figures out the pull requests, and basically just makes a bullet list. And it looks at the tags on those pull requests as well. So we can say, hey, here's all the bug fixes, title of PR, link to PR. And so that way you get at least high level real quick. And then for us, when we make the release, it's just clicking a button, it generates that list for us. And then if we want to go in there and refine it after, we can. But I think that's been, I think, one of the best routines I've seen so far.
Gotcha. Because the code is co-located with the documentation, you enforce that on pull requests and things like that? For the documentation is updated usually?
Yes.
Cool. Thanks.
Yeah, and having the documentation or most of it co-located with the code, like, will allow you to very easily leverage like CI without being too like easily. It's like a good thing to do.
Okay, sounds good. Thanks.
I have a couple of follow-on questions to that. So you mentioned an automated release notes script. Is this something in addition to the GitHub feature that just basically prints all the titles of the PRs, or is it more than that?
Yeah, I'm sure that Bain and JC have some solutions. I know with ITK, we have a similar way of processing commit messages and generating categorized by the type of the commit and the summary of the commit message, the parts of the release notes. But there are some systems that are built for languages like JavaScript has a fairly standard and really powerful set of common tooling for this called semantic release, and commit is in, and it will enforce these formatting of the commit messages and also generate summaries for you. Another really neat beneficial way of doing this automatically in GitHub, I don't know if you've seen this yourself, but if you go to create just a release with the GitHub web interface, and there's a generate release notes, and that's not as featureful as a lot of these semi-automated systems, but it works and it's very helpful, and it can give you a nice summary. And that's kind of a great way to get some release stocks. I think overall, to the question in the first place, releases can be delayed because writing the release notes, as JC mentioned, can be a blocker to the release, and also just manually, some projects keep a manual change log of when reviewing pull requests added to the change log and create a summary there. I think those automated methods are helpful, but yeah, doing a manual summary too at the end is awful often.
Yeah, and the manual summary, I think it's important to have an editorial role, because you still, like, depending on the fit, you want to put forward different things, and I mean, just a list of like bug fixes is useful. If it's not that useful to like present an overview, especially if you are creating an application. If it's a library, it's a little bit different, but for an application, I think taking time to what do you want to highlight, which images and all that is like important to take a bit of time for these things.
Kind of like the anatomy of documentation, there is an anatomy to releases that could be pretty standard that you can stick to or not stick to. And it also kind of has the same format of being very high level, down to a very detailed change log, but it's helpful to have, start with basically a summary of the project always, but then go into different levels of highlights of the release and a more edited version of the summary, and then get down to the change log at the end. A lot of details.
If you release often, these release notes are also smaller and easier to write.
Yes, and released often, yes.
Yes.
Within reason, but yeah.
I had a question. It's kind of about what JC was talking about mostly. And you gave great examples of how to grow and nurture developers that you have. But do you have any thoughts about, or I should say, contributors? Do you have any thoughts about soliciting contributors, or getting that process started, rather than just you've already got these contributors?
Yeah, I think depending on the community, like for example, if you organize a person event or virtual event that sort of provide an outlet for people to come together and get familiar with the community, that could be a way. Like attend sprint at conference. If you work like more like on scientific Python at SciPy, at the end of the conference, you have like this sprint. You could organize one around your project and then get momentum. Sometimes you have like folks who are not at all software developers, but they are really good at like writing documentation. They still want to contribute, and then you can sort of have them on your project. But like this type of event may be helpful. Meetup are also another one. If you have like local meetup, and then you can like, but yeah, event like that. A project in school. I mean, you are already in that context, but UNC every year there's like in the CS class, they are looking for like a mentor for students, and that's one way also to like bring people and sort of catalyst to have a catalyst for like future contributor and whatnot.
I'll add some thoughts on some luck I've had soliciting new contributors to software. I think it can go a long way when people are interacting with your software, whether they're opening like issues for bugs or discussion posts, things like that, and they're saying like, hey, I wish software would do this feature in this way, or could we tweak this parameter? And it might take you 30 seconds to go in there and make that change, but it can go a lot further if you just outline, you point to the line of code where it should be changed, you be utterly friendly with them and welcoming, you tell them how excited you are to have them on the project, and point them exactly where to go, and see if you can solicit them directly just to open a pull request and get people, because if you can get someone to just open a one-line pull request, that gets them comfortable with the code base, they've cloned it, they've followed some of your other instructions for development environment, they've done it for a small scenario, and so that way when the bigger thing comes, when they want a whole new function or a whole new part of the API, they have it all set up and ready, they're comfortable, they know how to open a pull request. It can really go a long way, I think, just to try to hold people's hand online and point them to the code and say, like, really, really work hard to encourage them just to make a contribution themselves. Yeah,
great idea.
And when they contribute, like sometimes even if you like tweak the change, making sure that you keep them as like the primary author and yeah, them like being the take all the credit, and that's the way make sure they are credited.
And I've seen on a handful of projects, one sort of way to gamify it is to add like a contributors list at the top level of the repo that's right next to the main authors. And so that way, and then sort of set up a way of like, once you get a substantial change, and that's super subjective how you define substantial, that person's name gets added to the list and they're like a code owner at that point. And it can be a way to get people excited about it, get people to feel ownership in the software as well that they're contributing to.
So I have a couple of follow-on questions. Probably the one I am most curious about is you mentioned the term like when you were talking about, inviting people to contribute once they, submit like a bug fix or small feature request. And you talked about being like overly, like as friendly and welcoming as possible. And that's more than just not being negative, right? Like in the code of
yeah.
In the code of conduct, I noticed that your code of conduct mentions not being negative, but to foster this welcoming community, it's more than that. It's like it's building on this this concept of showing there's like this whole kind of psychological aspect of this communication from the in community versus the newcomers kind of thing. Do you have anything do you have anything written up in your documentation about that, or how do you train people to help more effectively?
It's tough. That's a really great question of like, is that formalized anywhere? And I don't think I know of anything offhand that is formalized as like, how do you be utterly welcoming and make sure you're doing a good job of building community around your software and not, making people feel left out or feel like a newcomer that isn't welcome. And I think it's just, the main thing I like to think about is when you type up a comment online, it's the same as like if you're texting somebody or emailing somebody, it's like you have no idea how they're going to read that. And so it's like just use I can't think of the right term, but just like utterly positive words, exciting things, make it seem like this is the most exciting thing of your day. And that can go a long way in how someone interprets your comment and how they feel about interacting with you and if they feel welcome or not. But no, I don't know anything offhand where this has been written up.
Yeah, maybe
excellent
I
point.
mean, even a link to a blog post or something that might describe it would be super helpful. I did one of the reasons I asked is because PyCon, I did go to PyCon this weekend, and they had a whole keynote on basically this kind of communication style, how to, instead of saying, somebody asks a bad question, instead of responding, that's a bad question, you say, I don't understand your question, please clarify this aspect of it, kind of thing. Like it's something that can be often overlooked, but sometimes not obvious to everybody, especially more technically minded people.
Yeah.
There's different aspects to it. One thing that we found that's very helpful recently is there's an automated GitHub action that's called the first interaction GitHub action, and you can write automated messages to people when they create an issue or open a pull request, and it's automated. You think it wouldn't, okay, that's not very personable, but you can write the content in such a way that you note to the person that, hey, you're welcome here, and we appreciate the efforts that you're making, and also provide links to the code of conduct and indicating the culture of we have a culture of being welcoming and being collaborative and working together. And I think it is helpful and goes a long way that if people are met immediate with this welcoming message, you can include emoticons, which controversial, but I think it's helpful to have a little, little smiles, little some emotion in the text in some way, and let people know that, yeah, this is a great social contribution and it's appreciated. So JC, you're sharing your screen, by the way.
Screen is still being shared.
Yeah, I was looking for a link about some, yeah, we'll do that and find it.
While you're looking, can I ask, Matt, you had a good diagram about, it's like a documentation pyramid with like, I think a mission statement, and as you go down, examples, and then reference guide. Is there like an industry standard term for that? Because I've kind of advocated a similar thing in my group, and I've had trouble communicating it. It'd be great if I could just say, refer to some standard thing.
Yeah, that's a great question. And I think JC started out with a link to this open source.guide, which is one resource. I mean, there's many different resources, but that's one of my favorite places of going to that talks about how to do open source in many different ways, including community-driven open source. And I think they may have a good reference that the open source community, the Red Hat community, large community, put a lot of different people put a lot of effort into that, and it's quite helpful. Open source.guide, yeah.
And this,
You found the link?
yeah, and it's like the social rule. It's like another set of like, also common sense, but like how to be welcoming and whatnot. And it's called like the avoiding like backseat driving, subtleism, and etc. etc. And there are like five bullet points, but I find them always informative.
Yeah, yeah. I mean, sometimes it feels like common sense, like, and if you think about it enough, it is, but like it's easy to forget as well, even for more experienced people.
And like to like welcome like people in community, like, well, not, I mean, we all speak English, but for example, sometimes when people use acronym, it can be alienating. And like a thing that initially when I first came, I was seeing like FW, what is it? FWIW, AFAIQ, FYI. I mean, the list goes, and I'm like, what are these things? I have no idea what it means. It means that sometimes in our community, we use like just the word PR. What does that mean? Like, or MR. And if you're not familiar, like merge request, pull request, and I mean, position now is really efficient. It means typing things completely, especially if you like, I mean, if you talk to them every day, like in your casual chat, fine. But like with newcomer, like sort of being explicit and is go a long way to like create this sort of atmosphere of encouraging contribution. But yeah.
Thanks. I have a question for Matt about the, wait, was it Matt or Bain that talked about the automated building snippets? It was Bain, I think, actually. But if, Matt also can answer if he wants. So I guess my question is, so you said the snippets were building automatically from the code headers, I guess. Is that right? Or is it just pulling the snippets?
I guess I'm trying to understand your question. So in your document,
go ahead, yeah.
I'm just thinking, so like the way I would structure this typically is like you might have a markdown file that says, here is a workflow, describe your workflow in plain text. And then you do like the 3 backticks and you have a code block. And in that code block, you write your code snippet. And that's just, yeah, exactly right here, like JC sharing on the screen. So it looks just like that in a plain markdown file. Then you can use tools like mkdocs or Sphinx to actually like go in there and it runs that in a live interpreter and validates that no exceptions happen.
Yeah, okay, so that's, yeah, so that was my question, whether it was just, because you also mentioned that it was, you have your automatic building documentation from your code base, which has some kind of function header, which then could include a snippet. And then, yeah, so I wasn't sure if it was just polling the snippets or testing them. So, but thanks for clarifying that. And most of the snippets you showed were Python. Does this, hopefully this is a quick answer. Like, does this support other languages as well, like C++ and stuff like that?
Yes, yeah. I think the tooling has really blown up and taken off for Python and the Python ecosystem. And that's really where a lot of this stuff, I think, got most of its foundation, but it has been extended to run and validate all kinds of other code. Like just the fact that you can run C++ in a Jupyter notebook these days is kind of a testament to that. And here I think JC's pulling something up, but it's definitely the case for JavaScript, Python, C++, I think you name it. But a lot of the tooling was built around Python, and so that's why you're going to see Python as the key example.
Yeah, for sure. And it's the one that, is most friendly to use to new users, at least.
Precisely.
Okay.
A few specific tools are, yeah, the Sphinx gallery and the MB Sphinx. And I'm not sure which one Bain uses, but they will run these Jupyter notebooks if you have some of them that people can take themselves too, but generate documentation from them and also verify that the notebooks ran.
Yeah. Yeah, I mean, I've heard of the NB. Oh, yeah, I was trying to get NB Sphinx to work on something, but never actually got it to work. So I heard of some of these for at least notebooks, the Jupyter notebooks. But it's, yeah, I didn't realize you could do it for snippets too. So that's awesome. Are there any other questions from the remote attendees?
Yeah, I think I got one. So if I have like an unversioned web-based software where we're not releasing specific versions, rather it's like a continuous live like production server, how would you recommend having like version documentation for that? Or do you have version? Because I know one of you mentioned in scientific settings where someone will be writing their paper based on a certain version that should be replicatable. But if the software is changing live without versioning, what do you think the best way to go about that documentation is?
I'm going to give you a not great answer, and that's start versioning your software. I don't know, JC or Matt, do y'all have any? Because I'm thinking if you're building a web application, you're likely building a web API to accomplish that or to accompany your web application. And typically, if you're building your web API, your API endpoints will be like V1 and V2 and things like that. And it's very, very common practice to version web interfaces as well. So my non-answer here is, well, maybe version the actual software as well. Yeah, I don't know.
And there's few aspects like what is the artifact? Are we creating files that are generated from there? If they are files, is the file format documented? Is that versioned? And then it's also depend on the context and what is the tool used for? Because yeah, a live website will not be live the same one in like 3 years or 5 years. But then if you have clear documentation on what you create and how to interpret it, then if someone wants to come reproduce in that context, they will be able to understand and like use maybe different tools to reproduce the results.
What I use for this problem or approach or desire is hosting on a service called Fleek. And that's one option. There's different options, but this supports a standard that's used in Web3, the interplanetary file system. Basically, if you have a client-side web app that is a series of files that has a root, internally it's creating this immutable identification for the entire website that is a DAG, starting from the root of the website and then all the files in it, and each file has a hash associated with it, and then the folders have a hash associated with all the files, and so you get to a root hash, and that root hash is unique based on the content of the website, reproducibly, and so it can be hosted many different places, and you get the same data redundantly hosted. That's why you get this decentralized kind of self-identifying redundancy. But then you can every deployment of the website is identified with this root hash, and then you can always go back to that root hash and like a git hash basically, but for websites. So.
Cool. That's awesome.
Yeah, that could be like an entire different talk about Web3 and whatnot matters. Interesting things. You worked on scientific publication and open source journal, and yeah, that's yet another aspect.
So I have a kind of somewhat related question, and I don't know, maybe we need to wrap up soon. But like if if your web app is another distribution of a different app, and hosting the documentation separately or together is each come with their own advantages and disadvantages. Do you have a way that you decide how to merge existing documentation into that I guess to avoid repetition, like I think it was JC that mentioned. So I guess one of the examples that I can see is like PyVista is a VTK interface essentially for Python, and so like how do you balance like the you know, the new stuff in PyVista versus the old stuff that's in VTK?
That is a really great question, and that is a tough problem to solve. And we've been half the battle of developing PyVista has been managing that problem, because VTK has been a moving target, and then our users are adopting PyVista as a moving target, and making sure whenever because users fully control the environment, or we have no, the better way to say it is we have no control over the environment the user is using PyVista in. And so that means they could be installing VTK from whatever version, and then we need to make sure PyVista works across all of those versions, which has led to a lot of cruft in the code base of basically like, are you at VTK version 8.1.2? And do this. What about 8.1.3? Do that. And then 9 and up, do this. And it's been a pain. Very recently, we dropped support for version 8, and that's really helped clean up and optimize and fix this scenario, especially as PyVista and VTK are coming closer and closer together. It's a tough problem to solve, and it depends on the software stacks you're building and what they're leveraging. Yeah, and you can quickly just find yourself only working on that problem. So it's just a tough problem to manage. I don't have any quick and great advice for you, other than, I'd be happy to talk with you more about specific problems you're facing and help brainstorm things, but without getting specific, it's tough to give you any sort of valuable, useful advice.
I think the first step is to acknowledge their issue and not be like, not be like, oh, everything is fine, and acknowledging that things are not perfect, and then working toward improving. And for example, on the VTK side, now we have, I mean, that's new from yesterday, but and I appreciated Matt adding the screenshot, but and then ultimately that will help with PyVista, because we're going to try to also, for example, the supported file format in a meaningful way in the website and whatnot. It means, and that also make documentation for other applications easier, because they can back reference the documentation in the underlying library that will be versioned and all of that. But yeah, it's sort of is like back and forth, and having the PyVista one, you're like, okay, great documentation is a thing and it's possible. Then erase the bar, and then you're like, oh, let's also try to climb up to that bar also. It's nice to have that.
Yeah, that's cool. Thanks for those answers. Are there any other questions from the remotes people? I think then we should, call an end to this this panel, and really appreciate the speakers. So let's give them all a round of applause.
Thank you.
Thanks everybody for coming and all your questions. We'll post a summary when we can.
Document it.
Thank you, Jess. Thank you, everyone.
Thanks a lot.
Thank you, everybody.
Thank you.
Thanks so much.
Bye.